Hello everyone and welcome to your lesson of physics. So this is the video in which I'm going to explain question number 1 of paper 3, AS Physics paper 3, the practical paper. And I'm going to explain each and everything that you need to know for question number 1. So you need to keep this in your mind. The practical paper, it always has a specific pattern. If you understand the pattern of question 1 and question 2, you can easily attain good grade in that. So I'm going to start off with the first one. In this one, you have to set up the apparatus and you have to perform accordingly. For example, this question is generally about the oscillations, about the moments, could be about the spring, but there's a very good chance that the question number 1 is from the topic of oscillations, in which they ask you to find the time period. So in the very first part, you just had to set up the apparatus, and for the next one, they ask you measure and record the distance h. Throughout this experiment, do not change the distance h. Okay. So for example, for this one, the h was the maximum possible value of h was 80 something. So I'm going to write as 80.0 centimeters. So keep it in your mind, whenever you're noting down the distance through the meter rule, whenever you're noting down the distance, whenever you're measuring the distance through the meter rule, then you have to consider the least count of the meter rule. So in centimeters, so let me start off with the smallest one. In millimeters, there is going to be no decimal place. So for example, the answer was 5 millimeters, so you write 5 millimeters as it is without any decimal place. If they ask you to write in centimeters, or if you are writing in centimeters, then you leave the answer to 1 decimal place. And if you're writing the answer in meters, then you leave the answer to 3 decimal places. Okay, because this is the least count of the meter rule. Then for the next one, measure and record the distance x, this one, and I'm going to just write the answer. For example, this one is 5.0 centimeters. Okay, because if you read the question, they ask you keep the distance approximately 5 centimeters. So if you want to use it as it is, you can. So the first pointer, the general pointer from this one is be careful with the decimal places. If you're not being careful with the decimal places, if you leave the answer as, for example, 80 centimeters, you're not going to get the mark for this one. Likewise, if you write 5 centimeters, you're not going to get the mark for this one. It has to be 5.0 because that would correspond to the instrument that has been used for the process, which is meter rule in this case. So let me scroll down to the next one. By taking several of the complete swings, determine an accurate value for t. Capital T stands for period, the time period, time of one oscillation. So they say bring the pendulum, bring the bob up till this point and then release it. And when it goes to the other side, and then it comes back. Once it comes back to the same position, that is what we call one time period. The time it takes to complete one oscillation would be called as time period. Now listen to this one very carefully. Whenever you have to find the time period, which is time of one oscillation, you never take the time of one oscillation directly. Matter of fact, you take time of multiple oscillations. Okay, so for example, in order to find the time period, you have taken total time of 10 oscillations or 20 oscillations. Stopwatch. Keep the answer of the stopwatch to 1 decimal place. For example, let's say the stopwatch displays something like this. This is the side for minutes and this one is seconds. So let's say 30 and then it reads 0.46. Okay, this one is for the minutes, and this side is for the seconds, and this is the decimal places after second. So you don't try not to leave the answer as 30.46 seconds. It would be better for your convenience that you leave the answer of the stopwatch to 1 decimal place. There are certain pointers, there are certain things that you need to consider. So first of all, keep this in your mind. They have asked you to calculate 6 set of values of x and t. Include the values of t square in your results, in the table of your results. So what they're saying is you have to draw a table of x and t square. So 3 things they have mentioned that these 3 things should be there in the table. X, I'm going to highlight it, x and capital T and t square. Now the common mistake is many of the students, they would draw the table with these 3 column headings only, or probably they can add the serial number at the back, but the quantities, they'll keep these 3 quantities in the table. But you have to memorize it for a fact. Okay, I'm insisting you memorize it for a fact that whenever you have to draw a table of an experiment that includes the oscillation, you have to include first t1/second, which is the time of, let's say, 10 oscillations, t2 again time of 10 oscillations, t average, the average of these two, capital T, time of 1 oscillation, and t square, just hitting it on the calculator, the square of t. So in every question about oscillation, if you have to mention capital T on the table, in the table, then these 3 columns have to be there behind it every time. So whenever you get a question of oscillation, make sure in the table you have T1, T2, T average, and only after that you have capital T. Now, how do we fill the table? While you fill the table, you have to consider these important pointers. The very first one is range. And many of the students are not aware of it. So you see, you have to include the set of values for x and t. So x is the quantity that you're going to change. So for example, the starting or so what you do is the initial value of x was 5 centimeter. If you want to use the same value, you can use the same value in the table once again as well. If you want, you can totally use the same value. So we were shown the scripts of the candidates in A-level physics training workshop. We were shown the scripts of the candidates who had used the same value and they were awarded full marks. So you should be saving time and you can use the exactly same value as well. But the thing that I'm trying to mention here is the range. Okay, so how many values of x you have to take? You have to take, let's say, 6 values as it is mentioned in the question. Now you have to take 6 values of x. Okay, and x is the distance from the bench to the center of the bob. Okay, so you need to keep shortening the thread, and the bob would move up the bench, and you have to keep increasing the distance. So let's say the first value that I choose for x is 5.0, then 10.0, and after that I use 15.0, then 20.0, then 25.0, and then 30.0. Okay, so I've chosen this set of data, these readings for x. I fill it on the table. Now you see there is a problem in that, and one of the mark from the table is going to be deducted. The reason is the range. Now let me ask you a question. What is the range of this data? The answer is pretty simple, maximum minus minimum. So maximum is 30, minimum is 5, hence the range is 25.0. Now the thing is, the range of your readings should be at least halfway of the total possible value. So the maximum possible value of x was 80, and half of it would be 40.0 centimeter. And your range, the range that you have chosen, the data that you have chosen, the range for that data is not even 50% of this thing. It has to be at least 50% of this thing. So let me choose some other values of x instead. So instead of starting with 5, you can start with 5 once again. So like 5.0. What if I increase the gap? 15.0, 25.0, 35.0, 45.0, 55.0. 1, 2, 3, 4, 5, 6 readings done. Now what is the range of my data? It is 55.0 minus 5.0. What do we get? We get 50.0 centimeters, which is more than half of this reading, which is more than 40 centimeters. So make sure whatever situation you have, whatever the maximum possible value is, you should be careful that you should be at least covering, your range should be at least half of that value, half of the maximum possible value. Check out the next one. There was a question in which, okay, for example, this one. So you see, in this question, you were given with 15 paper clips, and you have to move the rod up and down in a certain way. So right now it is touching the chain number 6, clip number 6. So if you use the data like something like this, you move it to from 6, you use the first reading as 6, then 7, then 8, then 9, then 10, then 11. Your 6 readings been completed. Okay, but what is the range of your data? The range of your data set is 5. 11 minus 6 is 5. Now what is the total number of paper clips? What is the total possible values? 15. Half of it is 7.5. So the range of your values is not even 50% of the maximum possible values. 0 mark for range in the table. So the very first step when you're going to draw the table is you be careful with the range. Alright, so after you be careful with the range, after you have chosen a range, a certain range, the next thing that you need to be careful is the column headings. And when I say the word column headings, that means you need to enlist the quantity, you need to mention the symbol of the quantity slash the unit of the quantity. For example, x slash the unit of it, centimeters. T1, time of 10 oscillations slash the unit of it, seconds. T2, time of 10 oscillation once again slash the unit. T average, the average of these two slash the unit. Capital T stand for time period slash the unit of it. T square stand for the square of the time period, and the unit would be second square. So column heading means you have to mention the quantity, the symbol of the quantity, plus the symbol of the unit. These two things should be there. After that, we have the calculations. The values that you fill in the table, the values that you insert. For example, for the first one, we started off the table with 5.0, then 15.0, then 25.0, then 35.0, 45.0, and the final one was 55.0. So what is the time of oscillation when the distance x was 5? So you insert the value, you measure the value with the help of the stopwatch. You take the reading and you fill it over here. All right, you take the reading, you fill it over here. So whatever the reading is, that has to be written to one decimal place. For example, let's say the reading is 10.6 seconds. It was 10.63 seconds on the stopwatch, but we'll be writing to one decimal place. Okay, like I said, the quantities that you measure through the instrument, be careful with the decimal places. So which one are there to be careful with decimal places? Well, this one, be careful with DP, be careful with decimal places, be careful with decimal places. And T average, you don't find T average through the stopwatch directly, not from the stopwatch. You hit it on the calculator, you use T1 and T2, you use the calculator and you find T average. So you be careful with significant figures. Likewise, capital T is found through the calculator. It is a calculation. So significant figures. And for the last one, significant figures, once again, because T square is also obtained from the calculator. So let's say the value of T2, the time of 10 oscillations, after that was, let's say, 10.8 seconds. In the second attempt, you found the time of 10 oscillations, it was 10.8. Now you take the average of these two, 10.6 plus 10.8, both of them divided by 2, and you get the average 10.7. So this one has to be to one decimal place. Stopwatch recommended to write the answer to one decimal place. But for the third one, T average, we don't look for the decimal places, we look for the significant figures. 3SF, sorry, yeah, 3SF. So this one also 3SF. The next value, capital T, is T average divided by the number of oscillations. So T average divided by 10, it would be 1.07. Once again, we go for significant figures. How many significant figures? Back there, 3. So this one also 3 significant figures. And you take the square of it on the calculator. Whatever the answer is, you write there. But the answer, once again, has to be to 3SF. Whatever the number of decimal places are, the answer has to be rounded off to 3SF, 3 significant figures. So this is for the calculation. So you be careful with the range, be careful with the column adding, be careful with the calculation, be careful with the consistency, which I have explained already, that be careful with the decimal places. Now the rule of thumb is all the readings down the column, since all of them would be taken through the same apparatus, through the stopwatch in this case, so all of them should be to one decimal place. Whatever the previous reading is, but it has to be to one decimal place. So one decimal place, one decimal place, one decimal place, whatever the reading is. Forget about the significant figures. Answer has to be to one decimal place. Likewise, down the column to one decimal place. Alright, and in this one, for T average, you have to be careful with significant figures. So whatever the significant figures were there behind it, same number of significant figures all the way till the end. Because the time is for the same family quantities, quantity of the same family, or the quantity which is calculated from a certain quantity has to have the same number of significant figures. So same number of significant figures here, same number of significant figures here, same number of significant figures here. So down the column, decimal places have to be same, and to the right of the rows, the significant figures have to be same. They have to be consistent. Alright everyone, so now let's move on to the next part, which is part D of question number 1. So the first one says, plot a graph of T square on the y-axis and against T on the x-axis. So the very first thing that you do is you label the axis. Okay, like we do in O levels, IGCSE, in ADP, we label the axis. This is the very first part, and they have told you have to represent T square on y-axis and x on x-axis. So x/centimeter and T square on y-axis. On y-axis, you're provided with uh, 12 large squares, and on x-axis you're provided with 8 large squares. So what do we do now? The next thing is, after you have labeled the axis, you have to scale the axis. So you see the readings on the x-axis were starting from 5 all the way to 55. Okay, so let's say I'm going to start the x-axis from 5. So 5.0, then 15, then we have 25, then we have 35, then we have 45, then we have 55, 55.0. Okay, so this is how you can label the x, you can scale the x-axis. The rule of thumb is you have to cover at least 50% of the axis. Okay, at least 50% of it. If you cover 50% of it, then you're going to get full marks for the scaling the axis, even if you cover 50%. Now for the y-axis, we have to do the same way. We have to scale the axis in such a way that we use at least 50% of the y-axis. Another thing is, one of the axes, it would be difficult for you to at least scale one of the axes. They always put it this way: scaling one of the axes is slightly more difficult comparing to the other one. So for that one, we have a formula. So let's say the minimum value on the y-axis is 0. Let's say 12 second, and the maximum value on y-axis is 2.48. Okay, let's go with 3SF here as well. 125. Let's do 0.125. This is the minimum value that you have in the entire table or for y-axis, and this is the maximum value that you have. So what you do for scaling the axis is you subtract these two, you find the range of it, minus 0.125. Okay, you subtract these two and you divide it by the number of large squares on the axis. In this case we are using y-axis, so I'm going to divide it by 12. So what do we get from here? 2.48 minus 0.125, and this whole thing divided by 12, 0.196. So 0.19, what was that? 0.196. So this would be the scale if we have to use 100% of the axis. Okay, but we don't have to use 100% of the axis. We can find what should be the scale if we use 50% of the axis. So in order to find that, you can simply multiply this answer by 2. You can double the answer. So I'm going to do it. So whatever the answer is times 2, we get 0.39. So 0.395. Now finally, what I'm going to do is I'm going to find a very convenient, a very easy number that would make the scale convenient for us. So you see, you can go with 0.20. It would be in the middle of these two, or you can go with 0.25. In that case, you will be using the axis between 50 and 100%. So probably something like 60%, 70%. So what does that mean? It means after each large square, you have to increase the separation by 0. You have to step the scale up by 0.20. And what should be the first reading? You know, the first reading does not have to be 0. You can start from like 0.1. You can start off with 0.100. And after the first large square, you can write 0. There has to be a step of 0. Let's say we go with 0.20. So here 0.300, then 0.500, then 0.7, then 0.9. So this is how you can scale the axis. So once you scale the axis, the next step is to plot the data. So label plus scale the axis plus plotting the data. And after that, you can draw the line of best fit. That should be the final step. So you plot the data, then you draw the line, straight line of best fit. Then the next question is, how do you find the gradient and y-intercept of the line of best fit? So these are the questions that you're going to get all the time. In all the question 1 of paper 3, they are going to ask you the same questions. They will always ask you to find the gradient and y-intercept. So how do we find the gradient? For the gradient, we have the formula delta y, rise over run, or you can choose any 2 points on the line of best fit, and you can apply the formula y2 minus y1 over x2 minus x1. y2 minus y1 divided by x2 minus x1. But before that, you have to choose 2 points on the line. And make sure that points that you have chosen on the line of best fit, first of all, they should be on the line of best fit. And secondly, the points should be should be away from each other at a distance of at least 50% of the length of the line. So let's say if this is the total line, this is the line of best fit. Okay, so 2 points below, 2 points above the line, one here, one here, one here. So let's say this is the line of best fit. So the 2 points that you have to choose should be, one of them can be here, the other one cannot be here. These are too close. You have to make keep a separation of at least 50% of the total length of the line. So let's say the other one is here. Okay, and from there, if you want, you can draw a triangle. If you want to use this method, you can write delta y here, delta x here, whatever the values are, you can write over here, you can calculate. And the other thing is, if the values on one of the x's are too small, for example, all the values are 0.00178, then the next one is 0.00256, then the next one is 0.00347, then the next one is 0.00412. What do you do in that case? Well, you can plot only these values. So you can convert it into something like this, 1.78, and this would be 123 into 10 to the power minus 3. So likewise, the next one would be 2.56 into 10 to the power minus 3. The third one would be 3.47 into 10 to the power minus 3. Like 4.12 into 10 to the power minus 3. Then you have to scale the axis according to these values. And this factor can be compensated by writing this factor along the axis. So on the y-axis, where you write the quantity slash, you can write the exponent as well. The very same exponent that you separated from the values, you can write on the axis. So the very good way that you can practice this thing is, for AS students, a very good method is that you open up past papers of A2, which is component 5. You open up P5. In that P5, you have a similar question, and on this one you can, through the marking scheme of that paper, for example, you open up May June 2022 paper 5.2. Then you open up the marking scheme as well of that paper. From the marking scheme, you can get the you can fill the table, and then you can make the axis, you can scale the axis according to your formula, according to your working. And then if you open up the question paper, you scroll below the question, you'll find out that they have scaled the axis themselves. Then you can compare the axis that you have scaled with the one that they have provided. So I've explained this method in a short video. If you open up the shorts tab, you can see that method as well in detail. So now, once you have found the gradient, okay, let's say we have found the gradient as well. What do we do after that? We have to find the y-axis, y-intercept, sorry. So y-intercept is a point where the line touches the x-axis, touches the y-axis, provided x-axis starts from 0. So if the x-axis is not starting from 0, you have to find y-intercept through this method, y equals to mx plus c. And what do you do now? Well, what you have to do is you have chosen 2 points for the gradient. So for example, let's say the first point was 15 in 1.25, the second was 25.0, 15.0, 25.0, 2.75. So you have chosen, let's say, one of the point. You have chosen this point in order to find the y-intercept. So this is your x, this is your y. So you insert the value of x over here, you insert the value of y over here, you insert the value of gradient which you calculated previously over here, and then you can safely find the value of y-intercept. So if the x-axis is not starting from 0, you have to use the equation of straight line. So once again, the last part of question number 1 is always going to be like this. It is always going to be same. Just the quantities would be changed, but the process, the working has to be exactly the same. So you should focus on the method. Okay. What is the processing? What kind of method would be required? If you're compatible with that, if you have enough practice of the method, then whatever the equation is, whatever the quantities are, you'll be able to answer the question. So for example, in this one, we need to determine the value of a over b. So what you do is you write down the same equation. I can write the same equation like this. Okay, I'm going to write this last term first, minus bx. Why? So that I can compare it with equation of straight line, y equals to mx plus c. Now t square corresponds to this, okay, and x, once again on x-axis we had the distance, so the gradient of your graph corresponds to minus b. Whatever the value of gradient was, that equals to minus b, and whatever the value of y-intercept was, that equals to a. So whatever the value of y-intercept was, that equals to a. So what you have to do is you need to find the ratio a over b. So you write down the value of y-intercept, whatever the y-intercept was, you divide it by the value of gradient. Okay, so b equals to, b would be negative of the gradient minus the value of whatever the value of gradient was. Okay, so check it out from here. If m equals to minus b, then b equals to minus m. You can multiply by minus 1 on both sides. So the two values would be calculated already. It's just a matter of dividing these two. Now the last part is to give the appropriate unit. So the unit has to be the unit of a divided by the unit of b. The unit of a over b would be the unit of a divided by the unit of b. And how do you find that? What is going to be the unit of B? What is going to be the unit of A? Now, what does the A represent? A represents y-intercept. So whatever the unit of y-axis was, whatever the quantity was placed on y-axis, whatever the unit of that quantity was, the same would be the unit of y-intercept. So A in this case equals y-intercept. So the unit would be same as quantity on y-axis. On y-axis you were having t square and the unit was secant square. So the unit of A would be secant square divided by the unit of B. Now what is the unit of B? B was your gradient. The unit of gradient would be, so gradient equals to delta y over delta x, which is the unit of whatever the quantity is on y-axis divided by whatever the unit is for the quantity on x-axis. Okay, so let me just write it this way for your convenience. So you have the unit of A as secant square and the unit of B would be this thing, secant square divided by centimeter. So you can write it as this. To avoid fraction over fraction, many of the students struggle with it, so then you can keep change flip, secant square cancelled out, and the unit of A over B would be centimeter. So you have to find out the unit of whatever the quantity they have asked. For example, in this one they have asked you to find the unit of A over B. So you write down the unit of A and divide it separately by the unit of B, and you simplify the answer. So this is everything that you need to know about question number 1.